This is Steve Piloff from George Mason University. We're going to discuss perpetuities and annuities. They are particular cash flows that are relatively common, so we're going to look at them. Financial calculator in Excel can be very, very useful in looking and evaluating cash flows that follow these particular patterns. What we're going to do is we're going to use the financial calculator. We're also in some cases going to focus on analytical approaches because it helps reinforce the concepts, and in some of our financial models we're going to use the underlying analytical approach to perpetuities in particular to valuing stocks and other things. So that's our approach. What is a fixed perpetuity? Fixed perpetuity pays a fixed cash flow. So cash flow, cash flow, cash flow, cash flow, and notice it's fixed. Takes place regularly, and so in 1, 2, 3, all the way out forever and ever and ever, because it never ends. And this is really important, its next payment is in one period. So here we are today at time 0. In one period is that next cash flow. And then after that, every period, every month, every quarter, every year, kind of whatever the period is, it's going to make the same cash flow forever and ever and ever and ever and ever. So suppose I have an investment that's going to pay me a certain amount of money forever and ever and ever. What's the value of that investment? It's just the present value of all these cash flows, which is C over 1 plus R plus C over 1 plus R squared plus C over 1 plus R to the third plus C over 1 plus R to the fourth forever and ever and ever and ever and ever. That's what this equation is. Well, the problem is you can't add things up forever and ever and ever, but through the magic and beauty of algebra, this infinite expression simplifies, and simplifies truly to that simple expression. What is the regular cash flow that starts in one period? Divide it by the discount rate, and that is what the present value is. So C over R is equal to this whole expression. You can range that expression. So for example, if you know what the cash flow is and you know what the present value is, you can find the rate, which would be the one such that the present value of all these cash flows is equal to this. Or if you know what the value is and you know what the rate was, you could figure out what the cash flow was such that if you discounted an infinite stream of these by this rate, you would wind up at this value. So let's take a look at a few examples. What's the present value? What's the price of an investment? Pays $50 per year forever. It has an expected return of 6%, and the first payment's in 1 year. So in 1 year it's 50, 2 years it's 50, 3 years it's 50, forever and ever and ever and ever. Well, the value of this is 50 over 1.06 plus 50 over 1.06 squared plus 50 over 1.06 to the third, forever and ever and ever and ever. But we recognize, hey, this is a fixed perpetuity, not because we can see it at the top of the screen, because we can say, okay, look, fixed cash flows every year forever and ever with the first one, the next one in one period. So we know that the value is simply equal to C over R, which is 50, which is our cash flow that takes place forever and ever and starts in a year, divided by R. So the value is 833.33. So we have a loan. We're going to get $900 today, and then we're going to pay $50 every year forever and ever and ever and ever with the first payment in 1 year. And we want to know what the interest rate on that loan is. So what we're basically trying to say is we're going to get $900 today. In 1 year we're going to pay 50. In 2 years we're going to pay 50. In 3 years we're going to pay 50 forever and ever and ever. What we want to find is the rate. It's just that negative 50 over 1 plus R plus negative 50 over 1 plus R squared plus negative 50 over 1 plus R to the third forever and ever and ever and ever is equal to negative 900. Because we're getting 900 today, we want the present value of what we're going to be paying next year, the year after, the sum of all those forever and ever to exactly offset it. We're getting something worth 900, we're giving the bank something worth 900. Well, again, we recognize it's a fixed perpetuity, and we know PV is equal to C over R. You can do a little bit of algebra to get R is equal to C over PV. We know the regular cash flow is 50. We know the present value is negative 900. And again, you might say, well, the loan's 900, why negative 9? Because this is the present value of paying 50, paying 50, paying 50, paying 50. So the present value of all those payments, 50 in a year, 2 years, 3 years, 4 years, forever and ever, is equivalent to paying 900 at time 0. So the rate is equal to 5.56%. And so again, because we're dealing with a loan where we're making payments, that's why this example is good. You have to be careful. Negative signs. Finally, we have an investment. It's going to make fixed annual payments forever, and we're going to want to know what those payments are. What's the amount of that payment? If the expected return on the investment is 6%, the first payment's in a year, and the price of the investment is $750. So we've got an investment that's worth $750. We're going to get a payment in a year, and then 2 years, and 3 years, forever and ever. All those payments are fixed. So basically, what is C such that C over 1.06 plus C over 1.06 squared plus C over 1.06 to the third forever and ever and ever is equal to 750. The reason our investment's worth 750 as a price of 750 is because the present value of all these guys is 750. And again, we say, hey, wait a minute, that's a fixed perpetuity. So PV equals C over R. Do a little bit of algebra. C is equal to PV times R. And we know that the value of this is 750. We know the expected return is 6%. Therefore, the cash flow that's expected every year is $45. 45 over 1.06 plus 45 over 1.06 squared plus 45 over 1.06 to the third forever and ever and ever is equal to $750.